All right, let's hope this is loud enough. Um, I'm going to try to use Microsoft Paint and the browser, I guess, to help you out with this a little bit. I wanted to use pen and paper, but I didn't get a chance to get this ready, and I have to run to the office here in a little bit. I apologize again for not being able to meet with you to go over this. It can be a daunting subject for sure. But I hope this helps, and if you have any follow-up questions or whatever, feel free to let me know. All right, so the questions, let's just use the homework as an example, right? So I'm trying to see what the question, if you can see it. Okay, so considering the following network, 192.168.2.0, and then /24. What is the network part and what is the host part? I think this question will be easier to come back to once we've looked at the subnetting. But just to answer it ahead of time, the network part is this part, and this is going to be the host part. That will make sense. You know that because of the /24, and we'll go over that in a second. So what can be the maximum number of hosts of this network? Well, that's where you take the octet, right? And you know that you can get the possibility of 256. However, because you need the 2 reserved addresses, you can only have 254 hosts on that network with the /24. And again, the /24 is what determines that allocation. Again, this will all make sense after we go through the method that he taught us in class, how to do the subnetting. Okay, so here's the table. Let's go ahead and actually put the whole table together step by step. So let me make a note so I can actually see the numbers of networks we have. My cat destroyed some of the stuff I had sitting on my desk, so it's all over the place. All right, so he gave us the network's size of 15, 32, 120, and 20. Okay, so let's open up Paint. I think I have that right here. Okay, perfect. All right, excuse the writing. I'm trying my best with the mouse. I'm left-handed and I have to write with my right hand with the mouse. So first we have 15. All right, that's kind of big. We have 32. Oh gods. Okay. 120. What? All right. And then just we know that's a 0. And then we have 20. This is the quick method he showed us in class. It's also what we use at work just to make things easier on all of us. I have some notes here as well to help with this process as we go through them. Okay, so the first thing we want to do is put these into order from the largest to the smallest, right? This will help us allocate the subnetworks to make sure that we have all of the addressing done properly. So first, make sure I'm still on the same screen. Okay, the highest one we have is 120. So we're going to list those in order over here. All right, and we'll remove it from over here. The next up, we have 32. I'm trying my best. Okay, 32. We have 20. Whoop. All right. And we have 15. That's close enough. All right, so now we have them in descending order, right? So from the greatest number down to the lowest number. The next thing we want to do is set ourselves up for the final octet. So an octet is going to be a set of 8 numbers, obviously from an octet, and they start from the base of 2 to the 0th power, and they continue going up this way. As you get into bigger networks, you'll work with the other octets. But for now, I think this will make sense if we just stick to the last octet, which is all we need to know for the example in the problem that he gave us. So let's start at the very far, oh my God, right-hand side. And we have 2 to the 0th power. All right, that's 0. There's the octet for it. And then we'll have after that, let's hope I can make these with enough space, 2 to the 1st power, and the octet for that. 2 to the 2nd power. This is what you'll want to do on the exam to help you get through it. Honestly, if you don't have all these mathematical background that you don't want to do like the powers, if you just memorize them, you'll see it's a pattern. It's very easy to just fill in this chart like at the top of a scratch page or whatever when the exam starts, and it'll be easy from there. So, all right, 2 to the 3rd power. That's a 3, believe me. 2 to the 4th power. Okay. 2 to the 5th power. All right. 2 to the, that's a 2. To the 6th power, that's also a 6. 2 to the 7th power. And we'll add a 2 to the 8th power as well, just for demonstration purposes, but that's an 8. As all things in computers, we start with 0 instead of 1. So if we count from the left, from the right, oh my God, we have 1, 2, 3, 4, 5, 6, 7, 8, right? Okay. So that's the octet, the first octet. And then what you're going to want to do is look for the number that he gave us. So let's go back to the word example. The network that we're working with is a /24 network, right? So that's important. Let me make a note of that. So /24, that's important. I'm not a teacher, so I'm trying my best. The network is a /24 network. So that lets us know that we have as hosts all of the octets past 24. That will make sense here. I promise. Okay. So, starting from over here, we know this is going to be the number of addresses that we can put in each of these positions, okay? So we know that if we have a /31 network, right, we'll go into the slashes next. We can put 1 here. 2 to the 0 power is 1. This is that pattern I was telling you about if you memorize this. I'll try to summarize all this at the end, so if it doesn't make sense, hopefully the summary will help. This is a 2 here, 2 to the 1st, okay? And then 2 to the 4th, all right? 2 to the 3rd, which is 8. If you can see the pattern here now, it doubles, right? So 2 to the 4th would be, 16, all right? And 2 to the 5th, 32. I swear that's a 32. 2 to the 6th, if you can tell that that's a 6, we have 64. 2 to the 8th would be 128. I'm not at all looking at a cheat sheet because I can't remember the basic math. And then 2 to the 8th would be 256. Okay, so now what we want to do is go back to our example so you can see in the charts here. The first network that he gave us was the 120, right? We put them into order over here. So what we need to do is look into one of these and see which one of these would fit this number, right? It doesn't have to fit it exactly, it just has to fit it enough. So for instance, it won't fit into the 64 network. It will only fit into 128. There will be some unallocated space in that network, but that's okay. It's not the end of the world. And that's where if you see over here for the first network that is 120 addresses, we have the 25. Let me show you where that 25 comes from. Right, so here is a /25. As I said, we were working with the final octet. So right, 1, 2, 3, 4, 5, 6, 7, 8. So here's the dot in the IP address, okay? This is what we mean by the hosts, the host part of the octet. And the network part of the octet goes this way, okay? So over here, okay, they go up in descending order. So up here would be a -24. So we know when we're told that we have a network that is a /24 network, we're going to be working with hosts to the right of the /24 on the hash chart. This would continue. There would be an octet for, so we have the IP address that he gave us in the exercise. Let's take that as an example. 192.168.2.0. Let me write that into our paint file. So I swear that's a 9, 92.168.2-0 /24. This stroke here is what lets us know where we begin moving from when we look for available hosts when we're doing subnetting. So the stroke 24 here means that we're going to have available to us anything down this way. And again, these now go in ascending order. So going up to the second octet here would be stroke 24, 23, 22, 21, and so on. Same with this one and same with the other one. He's not going to give us, I don't think, any problems that deal beyond just the final octet. I hope that makes sense. So let's label these octets first, just so we have them. So again, ascending order going this direction, so 26. A good way to remember this is that you go with the availability of resources, right? You're going to go from right to left in ascending order. And then for the strokes, it's the reverse. So if you can just remember this pattern here, and you can remember that this is 24 at the first octet, you go this way, and then you go this way, right, with the counting. I hope that makes sense. So 26, 27, that's a 7, 28, 29, that's my partner, she's messaging me from Belgium, 29, 30, 31, and 32. Okay, so as we can see, this is now the full chart that we needed to solve our problem. So we see here that we have 120. What will fit that? A stroke 25 network, right? Because, oh, I didn't see that the numbers were all, let me move my camera. Can I move this? No. Okay, wait, hold on. How do I use this? All right, let's move over here. All right. I'm sorry. Let me re-explain this now that it's all in vision. Sorry, this is so long. So, the stroke 24 is here. That's this dot right here. The first dot that you're going to encounter in an IP address. This will continue to go this direction towards the left, and these numbers will continue to go down, whilst these numbers continue to go up. These numbers are the ones we're looking for when it comes to allocating IP addresses. So I think once you see an example of it, you'll be good to go. So let's work through the example given in the problem. So we have to find which one 120 can fit into. We can see that the only option for 120 is a stroke 25. So let's go ahead and note that. So for the 120 network, we're going to be using a stroke 25. All right, that's one. For the second network, we need to look for 32. What fits 32? All of these will fit 32 as well. This is the closest though. It's actually exact, so it works out perfect. So this one is going to be a stroke 27 network. So we've got 32. And we're going to put that at a stroke 27. This will all be very important when we start actually doing the networking part of it. Next, number 20. What will fit 20? 16 won't fit 20, 64 will fit 20, but 32 is the smallest that will fit 20. So this is also going to be a stroke 27 network. So we take the 20, all right, and that is also a stroke 27 network. That's a 7. Now we have 15. Where is the smallest one that 15 will fit into? That's the stroke 28. That's the 16. I'll show you what these numbers mean in a second. So we take the 16, or 15, my bad, I'm sorry, the 15, and we're putting that into a stroke 28. Let me show that to you in the chart so you can see how that makes sense for the homework. Here we've got all of the different subnets that we've done, right? So we see the first one, which is the one for 120. Oh my God, where's the paint? Okay. That fits into the 25. The 32 and the 20 fit into the 27, as you can see here. And then the last one, which is the 15, fits into the 28, which we have here. Okay, so that's how this chart is super helpful for that part of the thing, fitting the things into the different spots, I guess. Now where do these numbers come in? The powers of 2. Again, you don't have to worry about the math, just memorize the pattern of doubling. So 1 doubles into 2, 2 doubles into 4, 4 doubles into 8, 8 doubles into 16, and continues on. If you had a more difficult network, you would continue that pattern going up, and the top pattern would also continue going down until you got to 0, right? 0 would be a massive network. We would never do something like that because that's getting into like IP level, ISP, Internet Service Provider level network allocations. We're not worried about that, and in our careers, the chances of us ever dealing with that are slim to none. So let's just worry about the last octet. But that's just the concept of it, so you have it for future reference. Okay, so let me see if I can move myself and this over a bit more. Okay, and then I'll move this up here. Oh, please don't turn off the computer. My cat. Okay. She has a habit of jumping on the computer and turning it off. This is why I go to the office to work. Okay, so the final part, let's put it all together. We have the first network. I moved that too far over, didn't I? We have the first network of 120, which is a stroke 25. We look at our chart and we see that stroke 25 is at the power of 2, which is equal to 2 to the 7th, 128. So we can allocate 128 addresses. The question asks us, you are the administrator of this network, you need to create 4 subnets. These 4 subnets have the needs of these numbers of hosts. Please create these networks and fill up the appropriate table below. So for the first IP address for this network, since this is again why you go from the largest number down to the smallest, so that the numbers continue to go incrementing up as the subnets get smaller, because you'll start to run out of addresses. So you want to address the highest number first. That determines if you need to move on to another octet or not. Luckily, he told us here that we won't need to do that. I hope this makes sense. So starting from there, we know that we have this. Because of the stroke 24, we know, as we can now answer from the first question, this is the network part. This will not change. This part will change. This is the host part, right? So this part can change. And again, how do we know that? Because of the stroke 24. So 24 is here. It's the first period, right? Is that what it's called? Point dot that we encounter. And that's the first one here. So we know this is with a stroke 24, this is the host part, this is the network part. So all of our addresses going forward, for all of these little networks down here, we'll start with 192.168.2. All right, I'm gonna try to do it over here. I'm gonna try to write it smaller. We'll see how it goes. So what is the first address we can use, not that we can use, but the first address in that network? Remember, we have to subtract 2 from the total that we can use for each of the subnets, right? So the first one, we'll do these in black and then we'll put the subnet part in red. So 192, that's a 9. 92.168.2.0. That's the first address, right? We'll go back to this. That's the first IP address. Now we know that the first usable for that will be .1 because we increased this by 1. We can't use 0, so the first we can use is 1. Or better yet, because we'll need it for the future networks, 1 over the first usable. How do I make this larger? Will this work? All right, I wanted to put this in red so it's easier to see. Okay. So the first I'm in the eraser. The first oh my god, now it's small. The first usable is 0, okay? The next the next question that he asks us to do is what is the maximum number of IP addresses that we can allocate there. So that's going to be this number here, right? Because he's asked us to allocate a subnet of 120 addresses. However, oh my god, where is this at? Because this takes up 128 addresses minus 1 because things start at 0, we know that this is going to continue until 192.168.2.127. All right? The octet is taken up, whether we use all of it or not. It's going to be taken up when it comes to what is the possible addresses within that network, right? That's what he's asking us here. What is the first and what is the last IP address? So you'll have to use the maximum number. That's why you want to find the smallest number that you can to fit the network that you need into, because otherwise it's wasted space inside of that octet. If you think about it in terms of bitwise operators, these will be on or off, ones or zeros. So this would be a 1 right now, as far as how the computer would see it. I don't think he's going to ask us to go into that, but just so you know, so like this is like taken in a sense. Reserved that amount of space. Don't worry about it too much. It'll get confused when we have multiple slash networks, but that's how that works. So 0 to 127, those are the IP addresses. She's attacking her thing. Those are the IP addresses maximum and minimum. So what is the first usable address out of these, right? The first usable address is going to be one more than this. So 1, can we still see this? Oh my god. Here, okay. 192. That's a 9. Dot 168. Dot 2. Dot 1. That's the first usable because 0 is going to be reserved, right? So the first usable 192.168. Well, I think I messed up. I put 1, so we'll see if I got the questions right. Hopefully he doesn't care too much, but it would be a 2 for our response because that's the address he gave us here. .1. Now, what is the last usable address? Well, again, we can't use the first and we can't use the last. So we're going to take this number here of the last IP address and subtract 1 from it. So that will go until 126. Okay, I hope that makes sense. We get this number, you take 28, right? And you subtract 1 from it to get the maximum and minimum, because remember we start at 0 with computers. And then to get the maximum usable from that, you'll subtract 2 from this, right? Because we have to take the first and the last out, the 0th and the 127th. So this is the max usable, and this is the range of them. What will be the subnet of this address? Well, we know from here, it's a slash or a stroke 25, right? So we see that fills out the chart here. All right, so let's walk through the other ones. Maybe we won't use the paint program. I'll try. We'll see how it goes. So starting for the next one, we have a stroke 27, but we're going to have the same network address, right? We'll have different hosts, but we'll have the same network. So we start with the 192. That's a 9. Dot 168. Dot 2. And now we have to look and see with what we're dealing with here. We started the last one, right? The highest it got to was not this number here, this one, because remember they're reserved. So the next one that we can have has to be 128, right? Because looking at the chart, that was the last one that was in that subnet that was prior to that. Whilst we can't use it, it's still reserved for that subnet. So when you start the next subnet, it has to be increased by 1. Coming back, we look at our size network. We've done now this one. We need 32 addresses. We determined that that will fit into a stroke 27, which is going to give us 32 addresses, right? So looking at our plan from the last time, what is that going to go up to here? Well, what we're going to do is we're going to take this number here, right? We're going to add that to it and subtract 1. And that's going to give us 159 right here. So 159. That, well, that's supposed to be a 9. Okay, that's a 9, 159. Okay, I hope that makes sense, right? So you're taking the 128, okay? You're looking over here and adding this to it, but then you have to subtract the 1 because of the way that that works in the math. Let me see if I can bring up the calculator and I can show you how that works. Okay, so we've got the 128, which was the last address. We look over here, we have a 32 network, right? So it takes us to 160, but we have to subtract the 1 because remember we're counting from 0. Technically 128 is our new 0. So that's how we got to 159. I hope that makes sense. All right, so for the usable addresses, well, we've got, this should be in black now. We've got 192.168. Again, this doesn't change. This is our network address. .2. And what is our first usable address going to be? It's going to be one more than this one here. So 129. Can you still see that? Okay. And then what is that going to go up to, right? Well, we have to use the allocated space that we have. So looking back at our chart, we've got one less than this one here, right? That doesn't mean that they're all going to be used, but again, it's the same pattern. One less than here. That's the last usable because we have the 2 reserved addresses. So that continues on to, let's see if I can get this to fit, that you can see it. 158. That's an 8. Okay. All right, so now that one's done. Let's move on to the next one, which is the network of 20 addresses. So just to start, we start with our 192.168.2. And then where's our first address going to be for this one? Well, if we look, we see that it's going to be one more than this last one here. So it will be 160. Okay, that's the easy part done. What's that going to extend to? Well, to fit a 20, we saw that we have to go to a 32 network address, right? Because it won't fit in the 16, and 64 would reserve too many addresses that we don't want to reserve. So again, it's going to be 32. So we're going to have to add the 32 to this. So let's bring out the calculator again. We've got the 160 plus the 32, right? But because of the reserved address, we have to subtract, right? Subtract the reserved address. And you can see here, we've got the 191. That's the mathematics that goes behind this. So that will extend to 191. And that's a 9. Okay, so these are the addresses that are assigned to that subnet. What are the usable ones? Again, we start with the 192.168.2. And then for this one, take a second to think. I'm sure you got it by now. You're going to add 1 to this one. So it starts at 161. And it will continue until 1 less than this one. So 190. Okay? Does that make sense? I hope that makes sense. So going back to the document, we can see these are the usable, and that's a stroke 27, just like this one is a stroke 27. Don't let that confuse you. You can have two of the same subnet masks within a subnetwork. It's just a matter of understanding this part here, what that corresponds to in usable addresses. That's why memorizing the power of 2's going up and memorizing these going down. So if you associate 2 to the 0th with 1 and 32, you can figure out the rest of these going up that way, right? So you'll count down 32, 31, 30, 29, and going up 1, 2, 4, 8, 16, right? If you memorize that and you like jot that down at the top of your paper, you'll be fine going forward as long as you understand this method of what we're doing over here. So let's do the last network. We've finished this one. We have one more to go. So again, we start with the same numbers. I should have started with these smaller numbers like the with 192.168.2. And what's the first address going to be? Not first usable, but the first address. It's going to be one more than this one here, right? So we're going to go .192, all right? And what's that going to extend to? Do you remember how we figured out what it's going to extend to? We use a stroke number. So using the stroke number, we've got 192 here. And what stroke number does a network of 15 fit into? It fits into a stroke of 28, and 28 is associated with the 16. So we're going to add 16. And then because it starts at a 0, we're going to subtract the 1 and get the 207 that we have here. So that is our range for that network. Now, what are our usable addresses for this network? Again, we're going to start with the network address, which doesn't change, 192.168.2. And now we're going to do like we did before. This is the easy part, to be honest. We're going to look and see, okay, well, the last one started, the last usable one, the first usable one was 192, so we're going to add 1 to that, and we're going to get 193. All right, and we are using a stroke 28, so we're going to need to add 16 to that, right? And get our, oh my God, our 206 here. I'll show you the math of that. So we've got the 193 address. We're going to add the 16 to it. But again, we have the 2 addresses that we can't use. And that's how we get the 206. I did my math wrong on that, but it's 206. I hope you understand it. Again, you don't have to do the math for that. That's the easy part. You just look at these and you subtract 1, right? And you add 1. That's how you're going to figure those out. These are the most important part. These are the only ones that you actually have to look at this chart and figure out the numbers for. Once you have these, it's just a matter of add 1, subtract 1, right? So add 1 here, and subtract 1 there. I'm in the way again. Subtract 1 there. I hope that makes some sense. I'm not a teacher, so let's just recap it really quick. Let me put this over here and bring this over here. For your chart, you want to memorize that we start at 2 to the power of 0, which is 1, and that is at 32. Memorize those. Just memorize those and you'll be good. And then for an octet, right, you're going to go 8 over and put a dot, and you're going to fill in this pattern going up this way by powers of 2 and going down this way by 1. That's your chart, your base chart. Okay, that's going to give you your stroke number, the number of addresses available in that. You actually don't even have to memorize this part if you don't want to, if you can memorize these, right? this will be more than enough for you. Then someone's going to say to you, I need a subnetwork of blah, 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 blah number of addresses. They're going to give them to you possibly in a random order. Well, first you're going to sort them from largest to smallest, and then you're going to look and see which one of these little brackets that number fits into. Again, so 120 fits into the 128 bracket, and that's a stroke 25 address. Okay? So that's going to be your subnet mask. This is your subnet mask. If they ask you what a subnet mask is, it's going to always have a stroke and a number after it. How do you determine your subnet mask? You put the nets in order, you look at your little chart, you find which one it corresponds with, boom, that's your subnet mask. Then when you're asked to figure out what is the first IP address of that subnet, not usable, but the first IP address of that subnet, if it's your first network that you're building, if it's your largest number, it will be. It's going to start at 0. And then you're going to go ahead and find what this number is minus 1. Okay, always remember minus 1 because everything is the new 0. I hope that makes some sense. If you have any other questions about this, please let me know. And again, once you have your available addresses, your usable addresses are very easy. It's just this +1, this -1, that's your usable addresses for that subnet in that subnet mask based off the stroke that you figured out, given the size of the network and which box it fills into. I hope that was helpful. If you have any questions, feel free to send me a message. If there's anyone else in our class that you think this video would be helpful for, send it to them. Feel free. It's a private link on YouTube, but I'm not concerned about that at all. Feel free to share it. If you think it can help anyone. I don't really have a lot of people's contact information in the class, so I don't know where people are at and what they're struggling with. Again, I apologize for not being able to meet with you. I apologize for the length of the video. I finished lunch. I wanted to put this together before I went back to the office. Again, any other questions, just ask me. This should be enough, I think, to have us do subnetworking that he's going to give us on the exam. I doubt that he'll give us anything more than this. But this is the method that he showed in the class. It's the method that we actually use in day-to-day life. Again, keep in mind, not all these addresses have to be used, but they will be taken up and assigned to that subnetwork, which is, again, why you're looking for the smallest block that it fits into. I hope that helps. All right. If you have any more questions, again, I will be there tomorrow before class. I'll try to show up a little bit early. If you text me that you need extra help, I'll show up even earlier. If not, no worries. I'll be there as usual a couple minutes before class. Feel free to ask me questions, and I can stay after as well if you want some extra help. Tomorrow I don't have to go to the office. But yeah, good luck, and I think you'll be just fine. This stuff is not too bad. Anything else in the class that you have questions with, feel free to ask. Let's hope she doesn't turn off the computer before I have a chance to stop this video. So, okay, bye-bye. Take care.